Now, you are one of the pioneers of Kubernetes, right? Everybody knows that. Yet you claimed yourself, this was in Germany, I believe, that one day Kubernetes will die and the replacement is maybe already here. What does life after Kubernetes look like?
Yeah, so I think if you're a technologist, then you would like to see progress. And so to me, what Kubernetes represents, it represents a checkpoint on everything we learned up until around 2015. That's what Kubernetes kind of represents. Some people would say it represents everything we learned up until like 2010. We know that you can have lots of computers participate in a distributed system. You can use a controller, scheduler to try to efficiently use all of that compute. We've learned that a long time ago. I think Docker gave us a set of primitives in which to build upon for the average person that's not at Facebook or Google. So you take Kubernetes and everything you learn from Puppet, Chef, and Ansible around configuration management. A lot of people don't realize that a lot of that Kubernetes manifests this idea of declarative configuration and then having a reconciler go and make it true. These things people used to experiment with in the early days of Puppet and Chef, just a different dialect, right? Instead of infrastructure as code, Ruby or Python or whatever your dialect was, Kubernetes makes it a little bit more official by saying it has to be data. Infrastructure is data. But the same control loops are kind of there, looking at the current state of the world and then reconciling it to be the desired state. That's an old concept that the world was ready for, in my opinion, only because Puppet, Chef, Ansible, those tools existed first. It wasn't a brand new concept to us. Maybe the dialect was different, but the workflow was somewhat similar. And so when you get Kubernetes with that kind of lens, you look at it as like a checkpoint of everything we know finally manifested into one system that most people found a little easier to use because of Docker and the way it worked. We already had this existing content. People were already making container images, the price of admission to Kubernetes. So Kubernetes lays on top. Now, the thing that's interesting about Kubernetes that I think a lot of people may not understand until they use it for a while is the same thing that makes HTTP interesting. If you look at HTTP through the lens of Nginx or Apache, all you see is a web server and a protocol for a browser to communicate to a web server and send information back and forth, right? That's the simplistic way to think about HTTP.
Yeah.
But if you take the protocol away from the web server and you use it as a common protocol, you can now talk to databases like MongoDB. You can now implement things like gRPC, where you have a bidirectional stream of messages going back and forth. And you have something that now just works across the internet, even when no traditional web server is involved, even when no traditional web browser is involved. So in many ways, HTTP has already outlived the initial roots in like a web server serving HTTP to some web browser. It's used for so many other things, still client server architecture because of the nature of the protocol. So if you take the Kubernetes style API, we go from Terraform, Pulumi, and the way you build infrastructure today, you kind of think about like a RESTful interface, right? Where if you want to create a VM, you can have people make 500 calls, right? Create a network, create a VPC, attach the VM to the VPC. Once it's ready, install the operating system, mount a volume, and do all of these things.
Yeah.
And that could be 5 different API calls. So if you actually look at a Terraform provider, you'll see some of them are actually calling multiple calls just to create one unit of compute. In the Kubernetes model, it's a little cleaner than that. It has 2 things that are important. It has a spec and it has a status field. And that status field is so powerful because it really helps you do this fully declarative thing. So you can say, give me a VM. I would like it to be in this VPC. Maybe you reference an existing VPC. You can say, I want it to have this much CPU memory. You get the idea. And so that object, now we give infrastructure a type system. And this concrete type, you can, when you first get the object, even if there's no code to process it, you can always say in the status field, this thing doesn't exist and no one's even looked at it yet. And then, even if you're not using Kubernetes, you can take that same declarative model and start to build a control plane that allows people to say, I would like the lights to turn on if you really want to do that. Or I would like to have this app running in Germany and Australia, but never the US. And you can give it that manifest, and then the status field can say, hey, Germany is done working on Australia. Verified, there's nothing in the US. Verified, there's nothing in the US. Your spec is still good. That's very powerful because then you can start to do pipelines. You can now have emission hooks that say, I'm looking at what you requested, and it no longer lines up with the policy. So now I'm going to change the declaration to match the policy, show you the diff, you can accept it, and then all the other control loops reconcile the world. That Kubernetes model, to me, will probably outlive Kubernetes as it should. And then we should get better implementations, right? Where if you want to do like edge processing, but you like that API, do you really need the entire Kubernetes stack? This thing like needs like a gig or more to just run on a node? Or could we get by with something that runs in a few megabytes that looks and feels like Kubernetes? And then long term, as people keep coming up with better types, you're going to get a type that's going to be like, run this app globally. And it won't even mention a cluster or a namespace or a zone. And so as you get this new type, maybe the current implementation of Kubernetes won't be able to handle a global service. You have to build something different. And that's what I mean by over time it goes away. Not saying that it's not important. Like even though we talk about Kubernetes a lot these days, right there is Linux sitting there 30 years later, still doing its job.
Yeah.
So that's what I mean by we need it to go away so that something new can come in its place and maybe borrow parts that are worth preserving going forward. But if we're still doing little Kubernetes clusters for the next 30 years, what the hell happened?
So Kubernetes is maybe the HTTP of tomorrow?
I think the Kubernetes API has kind of proven itself for those that know how to use it, that its API model is really, really nice because of the way it splits the concerns between the person that wants something and the responsibility of the thing that does it. So instead of a cloud provider like Amazon or Google or Azure making you call 5 different endpoints just to get a VM, maybe we can move to a world where you just say, I would like a VM with these specs, and let them handle the implementation details. And you can just delete one object or create one object. And I think that's the big game changer. We don't have that today. So if that becomes a new foundation in which we design these cloud-like APIs, I just think we just move in a better space and no Kubernetes cluster required to do that.
Interesting.